Hello and welcome back to the, I don't know, get ready for the tears, final session in our scientific inquiry series, looking at our craters on the moon experiment. Now, I don't know about you, but I am going to miss it after it is done. And we have had, we've had a lot of fun doing this one. Before we dive into what we're going to be doing today, we obviously have to introduce you to our very special helpers in the studio. Come on up, guys. We have some pupils from All Saints School here in Barry again. Give everybody a wave. There we go. Say hello.
Hello.
Hello. Now, they are going to be working hard here in the studio today, just like you guys will be back in class. They say they're ready. Are we ready? Yeah. Excellent. They know. They've got it covered. They might actually come in and step in for me in a minute because I think they are that well prepped. So thank you very much. We will be seeing you in just a moment. Is that all right? Yeah. Excellent. Well done. Okay, and again, still, before we dive in, thank you very much, guys. Before we dive into the focus of today's session, we obviously have to take a little look at some work that has been sent in from across Wales. So, Rhea, who have we got first?
Yeah, so we've got a school, Ysgol Foel up near Pwllheli. So you have sent in lots and lots of photos. We can see there from the screen, we have images of the surface of the moon with the craters. You've got some teamwork there. I can see you're filling in some data in a table.
And not a lot of mess, actually. What do you think?
No, not a lot of mess. They must have cleaned up. They must have already cleared up. Because we made a lot of mess, didn't we? Yeah. No, it looks like there's a lot going on. Loads of lovely images of lots of you working together very well on that experiment. Well done.
And we have to give a special mention, of course, to Ysgol Sant, who have sent in so much throughout the course of this scientific inquiry. We have been so impressed. That actually does, if you can see on the screen there, it looks like the surface of the moon. So, you know, you've created a fantastic model there. Loads of pictures of you guys carrying out the experiment. You've got your ruler in there, making sure that you're measuring your variables, keeping that.
And good, they did it on the floor, as we suggested, wasn't it?
Very good.
It's hard to do it on the table. So well done for doing that.
Yeah, and then this is our fave. There it goes. Look at that. We asked for videos of those asteroids hitting the surface of the moon, and you did not disappoint. That was a very good slow-mo, if you like, for that.
Just those balls they had arranged as well. Did you see that? They were amazing.
I didn't have a good look. I'll have another look afterwards. Thank you very much. Now, thank you very, very much. And remember, even though we are coming to the end of the session, we would still love to see anything that you have created during this series. It could be you sending in videos of your ball drop of the asteroids hitting the moon, or it could be anything you've done, any of your written work. Yeah, we'd love to see it all. So tag us on e-sgol and SparkLab on social media, or just get that sent in to us, and we would love to have a little look through what you've been doing. But now, the focus of today. Yeah, there it is. We warned you last week. This week,
what could it be?
What is it? It's going to be.
I don't know.
I know. We are looking at graphs, not just graphs.
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 And graphs.
Yeah, that's what we're doing today.
Okay.
Now, hope you like graphs. Read us. She's already told us.
I love graphs.
And what we will be doing, and we've actually been a little bit busy since we saw you last. Ray and I challenged each other with producing our very own graphs, but we didn't do them like you will be doing them in session today. We thought we'd try something a little different. So we're just going to show you the graphs that we created. I'm just going to scooch around to this little camera around here. Sorry, Ray.
And it's up to you to decide, of course, whose graph you think is the best. You can let us know.
Now, I didn't realize it was a competition until Ray said that. Now, here we go. Okay, I have got this graph that I have created. I hope you all like it. Yes, I used a little bit of leftover Duplo. Let me just lift that up to show you there. Really importantly, and this will become clear later on, I've got some key features on my graph. I've got a title at the top there. This says this is a graph to show the favourite subject of 20 children in a class. I have got, on this axis, I've got number of pupils, okay, going up in ones. And at the bottom, there we have our favourite subjects. We've got the words science, English, PE, art, Welsh, maths and music. And it'll come as no surprise to you. No coincidence. Look, what was the favourite subject in this, Rhea?
It couldn't possibly be science, could it?
Look, science was the favourite subject.
Definitely not fix the data.
Absolutely not. And it was very clear to see that from our graph. Look, it even beat PE. I'm quite impressed by that. Now, this is the graph that I produced using words and numbers. I made a bar chart, okay? Would you like to see what Rhea made? I didn't realise it was a competition.
Well, of course.
Swap places.
Let's have a look. No, I'm only joking. We've both made very different graphs, okay? Mine here, as you can see, is different to Mel's in that I haven't got any bars, okay? This is a scatter graph, okay? And you can see here, instead of words on the bottom, this time I've got numbers on the bottom. So this one here shows you a scatter graph for ball drop height against bounce height. So what I did here was dropped balls onto a surface and measured how high up they bounced off that surface. And there we go, I've plotted this graph. Now, you might be able to see I haven't used pen here to mark those plots. I have used Smarties.
How many did you eat through the making of that scatter graph?
I definitely didn't eat any Smarties. This is exactly how many were in that pack. So that was very convenient, wasn't it? And I also, you can see my title here, which shows you exactly what this is all about. A graph to show how ball drop height affects bounce height. Now, I think that's a great scatter graph, personally. What do you think?
I think it is lovely. We won't decide who the winner of the graph is right now because we can't actually, because the graphs are very different. What we're going to need to look at today, okay? I chose a bar chart, Ree chose a scatter graph. We're going to have a little look and have a think about why we would choose a certain graph. Before that, why do we even plot graphs in the first place, okay? What different types of graphs are there? We've just shown you two. And then that very final question of how do we know which one to choose? So let's start first of all with why do we plot graphs in the first place? Well, imagine if I show you, we haven't got balls in our nice glass jar today. We've got lots more of that Duplo. Now this, if you imagine, is like numbers in a table, okay? It's good, we record them, we can see roughly how many we've got in there, but it's not very clear. And what a graph does is it helps provide, here goes Ree with my picture.
There we go.
It helps provide a very clear picture of the data, okay? It can help us to explain, we can see patterns clearly, and we can compare. We've got a few more graphs to show you, okay? Just to give you a couple more examples of this, okay? So if you have a quick look at this graph that is about to appear on the screen right now, as if by magic, there it is. Now, Ree, what is this a graph of here?
Okay, so this graph shows the number of goals scored by two footballers. You may have heard of them, Ronaldo and Messi. I think we've.
I don't think anybody likes Ronaldo and Messi out there today.
No, well, yes,
we got some disagreement in the studio here.
Now you can see how many goals they have scored every year since they were, what is that, 10 years old?
18.
I was thinking,
Ree's eyes. If Ree's eyes could read that from that far away, I don't know. Since they were 18.
Although, of course, they've been playing football since they were 10. That's what But yeah, you can see here data that's showing how many goals they have scored. And I think it's Messi. Now, it is quite difficult for me to see from here, but I believe Messi, age 23, scored more goals than Ronaldo, and I'm just waiting for confirmation on whether that's correct. My eyes do not deceive me. There we go.
But if it was a little closer to the graph, it might not have been so hard for her. But what you can see, the reason why we plot graphs is because we can see those trends and those patterns. We can spot data, spot information like that much more clearly and much more quickly than if we were just looking at a table of numbers. If you have a look at our next graph here, that is made obvious in this one. Now this is a graph, I'm not sure who has done this study, but it is a graph of the amount of sweets eaten in a week, I think. Now I know we don't eat sweets in the week, that's just saved for the weekends,
those
right?
Smarties, I'm telling you, I did not eat those Smarties.
Well, this graph here shows different year groups, or different ages, I should say, and I think it's very obvious which age eats the most sweets in a week. Apparently it's 9-year-olds. So any 9-year-olds watching out there, I don't know if you can concur this is true. But what a graph does is it makes data like that become very obvious as opposed to looking at a table. And if you have a look at one final graph for us, what graphs can also help us do, another reason why we plot them, is they help us spot something. Now, you might have heard this word before, but we may have said it last time, anomalies. Odd results. Now you can see from looking at this graph on the screen there that it follows a very clear trend until it shoots right up. Okay, and that is what we can basically say would be an odd result. It doesn't fit the pattern, the trend that is out there with the rest of the results. So we can spot these really easily or much more clearly when we plot a graph rather than just looking at a table of numbers. So that gives you a little bit of an insight and helps us explain how, or rather why, we plot graphs. If we just have a quick look, I think we should come to our experiment now because that's what we're going to be doing. If we show you, there we go, there's our table of data from last time. It's clear. It's a really lovely table.
Yeah.
Well, just blowing our own trumpets here. A really lovely table, but what it doesn't do is it doesn't help us see a pattern really clearly. So what we're going to work towards today is we're going to work towards plotting data from our graph. We're going to be plotting the independent variable, the thing that we changed, versus the dependent variable, what we measured. Now you can see we've calculated our averages from last time. We started to do that last time. We actually finished it with this set of data here. If we plot a graph from this now, we will be able to see whether there is a pattern or a relationship between the type of ball that we used in our experiment and the width of the crater. Now, before we do that, we should talk a little bit about what types of graph we could use. So let's have a quick look. Oh, there we go. Now, we've got a few different types of graphs up on the graphs and charts, I should say, up on the screen for you to have a little look at. Some of you might recognize the pie charts there, being nicely circled for you. How very apt. Ree, what might we use a pie chart for?
Oh, pie chart could be for percentages, for example. So that's often used. I think that's one of the most commonly used, probably, for you in the classroom. Okay. And then, underneath that, so under that, we've got a histogram, okay, which is used often for things to do with geography or the weather, okay, such as rainfall. A histogram is ideal for that.
Very useful in Wales. Not saying very much about the weather. And over there on the far side of the screen, you can see we have a line graph plotted and a line has been drawn. Those points have been plotted together. And then the two that we are going to focus on, that Ree and I spent some time creating for you, we will be looking today at bar charts, just there, and scatter graphs, okay? And what we're going to need to do in this session is we're going to need to work out when we would use each of those types of graph. Now, we've got a little game. Don't get your hopes up. We've got a little game for you now. We will ask our students from All Saints to come back. They're going to work as a team with Ree. Okay. And we're going to give them some scenarios. You guys can play along in the classroom as well. We're going to give you some scenarios and we're going to decide whether we're going to choose a scatter graph or a bar chart. Are we ready for these? Yeah. Now, the key thing here, what we've got to remember, don't worry, Ree's going to be working with you. I don't know if she's going to help you or hinder you. We'll see in a minute. The key thing that we're working with here is with our bar chart, what do we say that we have usually? It's going to be words and
numbers.
And then a scatter graph is when we're plotting numbers and numbers. Excellent. So let's have a look at our scenarios. We've got here, okay, names of pupils in the class. And their shoe size. If we were going to plot that, what do we think? What are we thinking over there?
So names, are they words or numbers? Names. Words. And shoe sizes are
numbers.
What we're going for?
Bar graph.
Yeah, bar chart.
Bar graph or bar chart. Excellent work. I think 1 from 1. Let's have a look at the next scenario. Good job. Okay. Length. This is a strange study that we're plotting here, but length of arm versus height. So pupils in a class, we studied those. Length of arm versus height.
Would we have a length of arm as a number or a word? Number, definitely. Well done. And what about your height? Number. So number and number. What are we going to choose? Do you know these answers already? That is fantastic.
Pros. Look at them. Scatter graph. Amazing. Hopefully you guys are getting the answers right in class as well. One left.
Okay.
Okay. Oh, well, obviously we had to choose the one that is going to be our experiment. We've got type of ball and width of crater. Do we need to confer? Do you need to have a little chat with Ree?
Okay. So do you think why do you think bar? So the width of the crater is a number.
What we're going with, guys? What we're choosing?
Decided.
Bar graph.
Bar chart, bar graph, what do we think? Oh, correct. Fantastic job.
Well done.
And as a prize, what you get to do in a minute is you get to plot a bar chart. What do you reckon? Is that all right? Excellent job. Right, if you guys go and get yourself set up over there, we will just have a little think about our experiment. Very good job. Hopefully you guys did as well in the classroom. We're going to have a little think about bar charts now, okay? We are in a moment, it's almost time for you guys to be plotting your bar chart. Hopefully this is something you have had a go before, but we need to do it for our experiment. Come on back in, Ray.
Okay.
Now, we're going to be, it's very important when we plot bar charts or when we plot any kind of graph, to make sure that we include four very important factors or four very important things. Now, what we're going to do, as if by magic, is we're going to just go to our little side camera over here. We like this today. And we're going to have a little look at how we're going to plot our graph. Now, let me just get this right so you can see it. Now, hopefully you should have some graph paper in the classroom, okay? And it is really important, okay? I've got a pen and a ruler set up over here, but when you plot graphs, you want to be doing this in pencil, okay? Pencils and rulers, please. Very good practice for when you head up to secondary school. Now, here are the things that we need to consider when we are plotting a graph. First things first, we need to have our axes. So if you can see here, we've drawn the lines at the bottom on the horizontal. This is our x-axis. And then we've got our vertical line up here. This is our y-axis. This is going to be the start of our graph. As you can see in the corner here, we've got a little 0, okay? Sometimes it'll be 0, 0, depending on what graph we're drawing, the origin. But for this one, for the bar chart that we're going to do first, just that one there, because if you remember, it's going to be numbers and words. So first of all, our axes, okay? Next, here we go. We need to put our labels in, okay? Now for our experiment, we've got, it's always the independent variable that goes on your x-axis. And our independent variable, if you remember, that was the thing we changed. It's the type of ball. That's what we're putting on our x-axis. And then on our y-axis, we've got the average. That's important. Make sure we plot the average of the repeats that we did. Average crater diameter. And it's really important in our labels that we put our units in. So you can see over here, you might not be able to see it very clearly. Lift it up a little bit. You can see that we've got centimeters in there because that is what we measured our diameter in. So axes, labels. Okay. Next, we've got our scale. Now, this is quite an important one. You have to make some quite, well, sensible decisions when it comes to your scale. For a bar chart, it's quite easy along the bottom here. We just put in the words of each of our type of ball. Now, it's quite important, okay, that we have the same sized space, okay? The intervals between them are the same, okay? And they're not joined up on this one, so we're going to plot our tennis, golf, ping pong, and so on across our bar chart. And then on our y-axis, we've got our scale for our diameter. Now, it's important that you look at what your largest value was. So if we were to have a think about our table that we had of our results, we knew that the largest crater was created by the tennis ball, and it was 10. So we need to make sure that our scale goes up to the largest value that we got. And it's also really important that we don't have random numbers. We need to pick a sensible scale here. You can see that we've gone up in ones, 1, 2, 3. I'm not going to count all the way to 10, but we've chosen something sensible so that we'll be able to see our results clearly. What you don't want to do for your scale is you don't want to pick something that is going to produce either a really tiny graph, or you also don't want to go up in completely odd numbers. You'd never pick a scale that went up in 3s or even 4s really, or 7s, nothing like that. What you can do is you can go up in intervals of 1s, 2s, 5s, 10s. What do you reckon, Ray? Those are the main ones that you'll choose.
Yes, that sounds sensible to me.
Okay, so we've done 3 things that need to be included on our graph. The very last thing that we need to remember to do is we need, as you can see there, a title. And this is a graph to show how the type of ball affects the diameter of the crater. It's really important to include a title on your graph, because if someone else were to look at your graph, they need to know what it's trying to show, okay? So, as if by magic, it's almost time to show you a bar chart that we have created, okay? But here's a little reminder. We use, I haven't got any with me in the studio here, but we basically use SALT as a bit of a checklist to see whether we have included everything that we need. You can see on the screen there, we've got scale, the numbers that you put on the axes, making sure they go up in equal steps. So that's our S, scale. Then we've got our axes, so the 2 lines, making sure we've got our X and Y axes. Okay, and then we've got labels, making sure our labels are clear on our axes, and then title. So if we have had a little, if you've already guessed, yes, SALT, SALT. We can use that as a checklist, there we go, to show us, to make sure we have included everything that we need. Have we forgotten our SALT? Have we got all of those things in there? So as you might be able to see on the screen, and I'd like to show you it in person, here is a graph that we've created for you, okay? We've started our graph to show the average crater diameter against the type of ball, okay? But some of you eagle-eyed viewers will see that we have something missing. Here it comes. Give you a bit of a closer one. There we go. We've plotted for tennis, all the way up to 10, golf, ping pong, marble, play. And Rhee, you didn't finish your graph.
I didn't.
Could you please come and show us? I think from the table, if I remember correctly, the value for bouncy ball was, what was it?
5.
5. So Rhee's going to just show you what we will do. Now, she's using a pen for this, but it's very important, like we said just now, that you are using pencil and ruler. So here she goes, filling in her last bar. Did she go up to 5?
Up to 5 there. Okay.
Excellent.
And then I'm going to the line across the top like that.
It's as if she's done this before.
I'll finish this here. There we go.
Excellent. And we have a completed bar chart for our data. Now, we haven't got time to colour that in right now. And when you guys set off and do this in just a moment, you might not have time to colour your bar charts in now either. That is okay. Do not worry at all. So what we're going to do, if I scooch around here, is we are going to give you 15 minutes, okay? 15 minutes in order to create a bar chart. Remember, you can use any graph paper that you've got in class. You can use the graph paper that we have provided. Don't forget SALT, scale, axes, label, title. We would love to see pictures of any of the bar charts that you create. You can, if you haven't got your data, you can use our results by all means, but hopefully you've got yours there in the studio, there in class, basically.
Yeah,
Anything I've forgotten?
No, that we just love to see what results you had for your extra 2 balls. So if you can send in any of your bar charts, that would be wonderful.
And obviously our pupils from All Saints are going to be doing this in the studio now. They are sat ready to complete their bar charts. So off you go. Hello and welcome back. Now, do not panic, okay? I've written that in big letters here, so I don't forget to tell you. But do not panic if you haven't finished your bar charts yet, okay? That was quite a lot to ask you to get done in that time. So we know, and also we know that you've been taking great care in making sure that you have included all of the SALT checklist. So have you got your scales? Have you got your axes? Have you got your labels? And have you got a title at the top? Now, we've been working hard here in the studio as well. We would love to see what you have created. So when you do finish, or if you are already finished, don't forget to use those QR codes and get those sent in to us, because we would love to see what you've done. And we would now love to show you what we have created here in the studio. I say we, I really didn't do very much hard work at all in those 15 minutes, but our lovely helpers from All Saints did. So let's ask them to come and have a little look. Let's see what you got. Ree, you coming up? Now, right, let's see these graphs. Now, you probably won't be able to see those as clearly as our graphs when we did them, because these guys have actually done it correctly. And what did you use to draw your graphs? Did you use pen? What did we use? Pencil. Fantastic. Pencil and ruler, and they worked. So you probably saw them on screen during that up in class while you were working as well. They were working super hard. Now, can I borrow yours for a minute? I'll probably mess things up here for a minute if I pop yours here for a sec. Absolutely fantastic. Now here we've got our labels, we've got our axes, we've got a really nice scale, beautiful handwriting, title, nicely underlined. And as you can see, we've started colouring in, didn't we? We started doing it. I say we, I did nothing. They've started colouring in. So that's definitely, you may or may not have had time to finish, but that's definitely something you can finish when you get back to class, isn't it? Yeah, really fantastic job. Well done. Let's have a little look at this one. Now, the best handwriting was going on for this one. Lots of concentration here. Look at these. We've got our labels. We've got our axes correct. We have our title, very neat title. Just pointing out here again, I don't know whether you'll be able to see because rules were followed and you did it in pencil. We've got our units, centimetres. So make sure when you check yours that you've got your units on here. Absolutely fantastic job. Really impressed, the pair of you. Do you think your work is over yet? Unfortunately not, because we've got another graph. Now, they were actually working really hard as well. Not only did they do graphs in that 15 minutes, they also did a really important job, because remember that we said today we were not just going to be looking at bar charts, which you've done beautifully. We're also going to be plotting scatter graphs. Now, bar charts, remind me guys, what kind of things do we have on our axes when we have a bar chart? Is it numbers and numbers, or is it numbers and words? Very good, and that's what we've done here. But for a scatter graph, we need to plot numbers and numbers. But we didn't have another set of numbers, so during that little break, well, I say it wasn't a break for you, what did you also do for us just then? You took all the different balls that we used in our experiment, and what did you work out? Very good. You weighed them.
There we go.
And you calculated their mass. There we go. Yeah, we've got, as if by magic, we've got one here. We've got our little, you won't be able to see it, but we've got our little scales that they used. And we've got here our little bouncy ball. And we worked out the mass of each of these balls. Okay. Very good job. Thank you for doing that. You saved us a very important job. Now, yeah, if you guys head over there just for a sec, I'll keep your graphs safe. I promise I won't steal them. Now, as you can see up on the screen there in front of you, we have got our table, but it might look a little bit different to you this time. It's still got the type of ball in that left-hand column. We've got tennis ball, golf ball, and it's still got all of our data, all of our width or diameter of our craters and our average. But you may have noticed that there is a new column being added. This says mass of ball. There we go, highlighted beautifully for us there. This is the mass of the ball. Now, as you can see, our units are in the heading, grams, and you can see the different masses. Now, we didn't do this just now, it was done for us, and beautifully so, might I add. We've got the tennis ball. How much did you were helping out over there, Ray? How much did the tennis ball weigh?
The tennis ball was the heaviest. It was 60 grams for the tennis ball.
The golf ball might have been heavier than the tennis ball. What was that one?
The golf ball, I can see, is 50 grams for that one. So quite heavy still. It's considering it's smaller, but not quite as heavy as the tennis ball.
And then we go down to some really light masses there. We've got the ping pong ball, which I think just weighed a measly 3 grams.
3 grams, yes, it was, but it's full of air.
Yeah,
so
that's true.
That,
yeah. But what we can do with this data now, okay, we can see it nicely in the table. We've got the masses, but we want to compare the mass of those balls to our average diameter of the crater. And the easiest way for us to do this would be to plot a scatter graph.
Oh.
Now,
I might take the opportunity to show this again in case you didn't catch this earlier. This is mine.
This is the scatter graph that she created, and definitely did not eat any Smarties in the making of that.
Definitely.
Now, we don't want you to create your scatter graph out of Smarties, but as an extra challenge, you absolutely could later on, 100%. But we're just going to show you, okay, going back to our little camera over here, we're just going to show you the outline and the things that you need to do when you are plotting a scatter graph. So here we go. We have to remember salt again. We've got a really good scale. If you can see from this one, our scale hasn't changed on this axis. We've got 0, 1, 2, 3, and so on, up to our largest crater diameter of 10. But then on the bottom, rather than the type of ball and words, we've now got the mass of the ball in grams. And a scale that we've picked for this one to make sure we can fit it on our line graph is we're going up in 5s. Keeping our interval the same. We've got 5, 10, 15, 20, and so on, all the way up to our largest mass, which is 60 over here. We made sure our axes, we're plotting the right thing on the right axes. We've got our independent variable on the horizontal, and we've got our dependent variable on the y-axis, on the vertical. We have labelled our axes correctly, mass of ball and average crater diameter, grams and centimetres. And then we have a title, similar to the last one, but rather than showing the type of ball and how that affects the width of the crater, now we're showing the mass of the ball and how that affects the width of the crater. So we have included salt in our checklist, okay? We have made sure we've got our scales, axes, label, and title all on our graph. Now, we have started, I say we, Ree loves a graph. She started to plot the scatter, the points on our scatter graph here to see if we can see a pattern or a trend in the data. Now, we've done all of the lighter masses. We've got 3 and 4. We've got one at 10, one at 20. We've got our golf ball here that had a mass of 50. So we're just missing, which one are we missing, Ree?
We're missing the tennis ball, if you remember from the table, weighs 60 grams. So
there you go.
The tennis ball, that's it. Brilliant. We've got there 60 grams and the average crater diameter is 10. So where those two numbers meet, I'm going to put a little cross. So just here, there we go. There's my plot for the tennis ball.
Fantastic. And hopefully what you might be able to see from our scatter graph that we have created with our data is we can see a pattern. We can see a trend. As the mass of the ball increases, Ree, what happens to the average crater diameter?
That also increases.
Now, that is much easier for us to see by looking at a graph than it is to see from our table of data. One of the reasons why we would plot a graph. Now, what we are going to do is we're going to give you some time at the end of this session. We're going to have a little work window for you to complete your scatter graphs. Now, don't worry if you don't finish in the time. Don't worry if you don't finish in the time. You can take as long as you like. But what we're going to do now is we're just going to give you a little bit of a teaser of what we're going to be doing in November. Now, I don't know if you guys know, but it's actually World Space Week this week. It couldn't have fallen at a more perfect time. And what you can see on the screen right now is we've got a little video of a rover traveling across the surface of the moon. Now, I don't know about you, but this looks very much like the models that you made in your classroom where you were dropping the asteroids onto your surface of the moon. You can see there it's covered in holes, craters, bumps, and it's quite hard, I think, for that little rover to travel across the surface of the moon. Now, I think in a sec, you're going to see another clip of a different type of rover. And what we're going to be doing, oh, here it is. This one might be my favorite. Give it a minute. There we go. Look at this. Very snazzy. I think Ree said she was looking for something like this for her next car. Was that right, Ree?
This is much nicer than my current car. So yes, possibly. A lot more expensive as well.
The reason, yeah, definitely. The reason why we are showing you these images of some rovers is in November, we'll be coming back to you for a quick 2 sessions, okay, and we will be setting you a challenge. That challenge, if you can see, I've got a little rover here, okay, here's my surface of the moon, and here I've got a little rover. This one has 6 wheels and is actually quite good at traveling across the surface. I've forgotten my remote control over there, so I can't turn that on for you. But what we're going to be doing is we're going to be setting you a challenge of designing your own rover and building a rover, and then doing a little challenge once you have created your rover. How many times can I say rover in one sentence? But that's what you're going to be doing. So we are really excited to be continuing. Oh, Susie, I like that. Yeah. We are really excited to be continuing this scientific inquiry away from the experiment that we've just done into a new challenge for you come November. But before that, okay, we will give you a little bit more information. We'll give you a bit more details. If you want to do any research in the meantime on, things that might be good at traveling across a really rough and bumpy surface, like the surface of the moon, have a little look at, we've showed you a couple of clips, but have a little look at some other rovers that might be out there, some that have already been designed, and have a think about how you could create something to replicate that.
I can't wait to do that. That'll be a very exciting few sessions in November.
Absolutely. Now, in the meantime, that very last challenge that we would like from you is we would love it if you could create a scatter graph for us. You can see ours up there on the screen for you. And don't forget that checklist, that salt. Have you got your salt, scale? What was the rest of it, Ree?
Axes, labels and title.
Very good. There's that QR code there, so you can send in your work once you have created it. Hopefully, if you haven't done scatter graphs before, having that there as a bit of a guide will help you. If you have, and if you've got graph paper where the grid and you can get different intervals, maybe you'd like to plot your results with decimal places. Now, if you haven't been able to weigh or get the mass of your of the different balls that you used yet, by all means, you can absolutely plot our results, or you could plot the first 4 because we all did those balls and they would be approximately the same. Yeah. But yeah, feel free to have a go with our data, or hopefully you've been able to take the mass of yours and you'll be able to create something like this for us. Like we said, we would love to see it. So if you can send anything in, tag e-sgol, tag SparkLab, and we would love to share the work that you have created across our socials.
Yeah, even if it's something you did a long time ago, like Mel said, at the beginning of this, please send it in. We would love to see it, wouldn't we?
And so all we've got to say for now is a massive thank you very much to our friends from All Saints. I know we can't see you right now, but they're giving you a really big wave.
Big smile. Yeah, well done.
Excellent. Hopefully they've had fun with us today. And you guys at home in the classroom for joining us. So thank you very, very much. And hopefully we'll see you for an exciting new challenge in November. Thanks very much.
Bye-bye.
Bye.